Alright, so I'm going to show you how to solve for wavelength, frequency, and energy. Okay. Usually you have these equations, you're talking about electromagnetic waves. So these are the three equations that you'll need. Equation 1, C is speed of light. This funky symbol is wavelength. F is frequency. Alright, so speed of light is equal to the product of your wavelength and frequency. You also have equation 2, which is energy is equal to h, which is Planck's constant, and frequency. E is energy. Alright, so you can look at the top here to remember these different things. Speed of light also, so I forgot to say, has this value. Now equation 3 is energy is equal to speed of light multiplied by Planck's constant divided by the wavelength given to you. Now if you forget these constants, which are C, H, they're found over here on the side. Alright. Notice that, and I'll zoom in for you. That you can have the speed of light, which can be represented as 3 times 10 to the 8 meters per second, but on some calculators it'll show it as 3e8. Alright, so you can use either or, it doesn't matter which one. Typically in my class I use this. So if you don't have these, you might want to press pause and then copy them down, including these values. Alright, so here's the first example. It says, what is the wavelength of an electromagnetic wave that has a frequency of 3.8 times 10 to the 10 hertz? Alright, so what I would do is I would just look at what's given. It says, what is the wavelength? So you know you're going to have wavelength. What is the wavelength? And it gives you a frequency. Alright, so you have these two variables, and if you wrote down those equations from earlier, you're going to look at which one would be best. Which one has wavelength and which one has frequency. So if we go back, you can see that of these three equations, only the first one has frequency and wavelength. So we know we're going to need C, which is a constant. If you're not so good with manipulating equations, you can use this triangle. If you look online, you might find different things, like for C, they might use velocity. For frequency, sometimes you might find V. So we're looking for wavelength, cover it up. It's going to be the speed of light divided by frequency. So let's show the work. I'm going to use a different expression. So we have our speed of light on top. You can divide it by your frequency, which is right there. So you're going to get a calculator. And you're going to solve for the answer. Now, if you're using these TI-84s, it's going to be 3. You have to push second, comma, and then 8. then the divide sign, 3.8, second comma, gives you the exponent symbol, 10. Enter. It gives you this number. You can remember your scientific notation rules, or you can just click mode, change it to scientific notation. And you get 7.8947. E negative 3, and the wavelength unit is meters. Now we have to remember significant figures. Okay. So from the problem, you're going to look at the numbers given. We have 3.8, so we only have 2 significant figures. So that means then we're going to have to round to 2 numbers. So your wavelength is going to be 7.9 times 10 to the negative 3 meters. Okay. So that's how you solve for that one. Let's do another example. All right, so what is the energy for an electromagnetic wave that has a frequency of 6.63 times 10 to the 7 hertz? So once again, let's just write out what we have. We have energy. That's what we're looking for. We have frequency. I'm going to write it out with a different expression this time. So we have these 2 variables that are given. Well, let's look back at our equations that we have that we were supposed to write down in the beginning. You have energy and frequency, so we know that can't use equation 1. Equation 3 doesn't have frequency, but equation 2 has energy and frequency. So we're going to use this equation. So we know we need the Planck's constant, which is 6.63 E negative 34. And it has weird units. It's joules times seconds. So the equation is E is equal to H times F. You could also have this little triangle just in case you struggle with manipulating, but it's pretty simple. It's just E and H and F. We're looking for E, so it's going to be H times F. So let's solve for it. You have E equal to H times F. So 6.63 E negative 34 joules times seconds multiplied by 6.63 E 7 hertz. The units are just there, so we know what we're working with. Let's get out the calculator. So it's going to be 6.63. Remember, you're going to use this second comma if you're using this calculator. Most calculators have that same function. Make sure you do negative 34. Don't use the minus sign. Some calculators will go crazy. Times 6.63, second comma, 7. And you end up with 4.39569 E negative 26. It's a really small number. Let's go back to our values. We were given 3 numbers from the problem. 6.63, they're all non-zero numbers, so they're all significant. Alright, so we need three significant figures. So our answer is going to be energy is equal to 4 point, this rounds, so 40 e negative 26. The unit for energy is joules. So that's our answer. Alright, one last example. What is the energy for an electromagnetic wave with the wavelength of 4.93 times 10 to the negative 7 meters? Once again, you're going to write out what you have. You have energy. That's what you're looking for. You have wavelength, which is this weird backwards y symbol, lambda. And then you are going to just write it out, 4.93 e negative 7 meters. Remember, these are exactly the same, they're just expressed differently. So we're only given two things. Once again, you look back at your equations. Which one will I use? We have energy and wavelength. Equation 1 has wavelength but doesn't have energy. Equation 2 has energy but doesn't have wavelength. So you go to equation 3. You have energy and you have wavelength. So you're going to use this one. Okay. So the equation we're using this time is energy is equal to speed of light multiplied by Planck's constant divided by wavelength. So we're going to have C, we're going to have H. You might be wondering, it doesn't say these values, so where are we going to get them? They are constants. All right. So we're just going to plug these in, all right, and we'll solve for it. 3, 8 meters per second times Planck's constant, e negative 34, divided by your wavelength. I would use parentheses, especially if you're going to enter it in all in one line of code on your calculator. Okay. So I'm not going to show you the calculator this time. You should be able to do it on your own. And this time you will get, let's see, I'm going to check my work because I make a lot of mistakes. Use this time to solve it for yourself instead of just waiting for me to give you the answer. Okay, I checked my work two different ways, got the same answer, 4.03448. So this is like an answer that usually kids who don't understand significant figures would give me. Now let's look back at our answer. We have 4.93, that's 3 non-zero numbers, so we know that these are all significant. So we need 3 significant figures as our final answer. Notice after the 3 is a 4, so we're not going to round up. We leave it as is. Your final answer for energy is 4.03 e to the 8 joules. It's a lot of energy. Alright, so just as a recap, make sure that you're using these equations. You know what wavelength symbol is, what the frequency symbol is, what the energy symbol is. For electromagnetic calculations, you'll have these 3 equations. Alright, sometimes instead of C, you'll also have velocity. Okay, so sometimes the equation can look like this. Velocity is equal to wavelength times frequency. But since all electromagnetic waves move at the speed of light, its constant v will always be equal to c. Alright, so you could also have this. Alright, so that's it. If you have any questions, please let me know. Thank you.